do it.
So let's jump in. This first one, I had these door catches for my closet, and the current ones I had several issues. The doors wouldn't stay
Oof.
closed. They had this magnet system that was quite old, and they had lost strength. A lot of the parts were worn out or just missing altogether. And anytime I tried to mess with it, I'd get covered in what I think was just the magnets eroding in my hand. So I knew it was time for a better solution. So I jumped into xDesign and made a simple door catch system. I started off making the pegs that would come down from the door frame and then designed the clasps around the pegs as a separate part. Really quick, simple design. I didn't want to overcomplicate it with any unnecessary moving parts. I kind of just wanted something that worked. And for the installation, I took measurements from the old system so I could reuse the existing screws. I copied the slot design from the original, so the screws could slide and tighten anywhere along the slot instead of just being locked into a single fixed hole. And when it came time to mount everything, I made sure to hand tighten the screws. Just a tip, if you're ever installing PLA printed parts, you can drill through them quite easily, as I found out the hard way. So I try to avoid using a power drill where I can. And so I next replaced the metal plates on the doors that used to stick to the magnets with the new plastic clasps. I attached them using some double-sided tape. So this solution actually used fewer screws and is a bit more renter-friendly than the old one. And the attachment worked exactly how I'd hoped. The clasp grabbed the peg just enough to keep the doors secured closed, but they were also loose enough that the doors would open easily. So simple, but really useful fix. And my 3D printer saved me a trip to the hardware store.
Wow, that's really cool. So, I mean, the first thing that comes to my mind with this, Noah, is a lot of times, you know, depending on how you print the part, like how you print the model, you know, it's going to flex in different ways, and like, you know, certain ways it's not going to be as strong as others. So like, what were the considerations, or how would you like coach somebody that's going to try to do like a similar project, or like what would you tell them as far as like how they could print it, or like what are some top tips for like this kind of thing? Because it's like a flexible part, right?
Yeah, that's a great question. So yeah, this part is interesting because it's made out of rigid material in PLA, but it is made to flex a little bit. So I wanted to make the plastic on these clasps not crazy thick, or else it just wouldn't move, it wouldn't grab onto the peg. And in terms of printing them, you're absolutely right. 3D printing is anisotropic, meaning it has different strengths in different directions. And some lessons I learned throughout making this video and printing these projects was you always want to print the part with the layers going in the direction opposite of the force. So for this example, the force, you know, is going towards the peg and away from the peg, which is also the same direction I wanted the layers. If the layers are going, you know, this way, they might get pulled apart, but this way it was perpendicular to the force. So yeah, question.
Very cool.
For this next project, I had these curtains that were already installed when I moved in, and they ran on a track system made of two separate pieces that were joined together. And the issue was whenever I pulled them closed, they would get stuck right at that point where the tracks joined together. And it was really annoying. So I started to think, all right, how can I fix this? And I knew I needed a way to smooth out the track. And to do that, it really needed to be a single continuous piece. But 3D printing a full track across the width of the ceiling just really didn't make sense. It would need joints and then might have the same issue as the original. So instead I thought, what if I used a wire as the track and just 3D printed the anchors to hold the wire in place? And this was another example where xDesign made it really easy. I created a slot for the wire, then added a knob at the end so I could tie the wire around it. And I also added a hole going through the knob so the wire was secure and would keep it from unraveling. And it took a couple prototypes, but eventually I came up with one that did the trick. The wire fit nicely in the slot and it felt secure when I tied it around the knob. And I used some double-sided tape again to secure the anchors to the wall. But from the moment I started putting the curtain on, I could tell something wasn't right. The wire was
Oh
sagging
boy.
pretty substantially, and after a couple seconds, this happened. Just complete failure.
Yeah.
So I knew I had to make a change. So it was back into xDesign. Double-sided tape wasn't going to cut it. So this time I added a few screw holes to make sure the anchors wouldn't pull free from the wall. I also used a bit of revision management tools, or a bit of the revision management tools in xDesign, so I didn't have to start from scratch. And I also didn't overwrite any of my earlier work in case I wanted to reference it. And the screw holes made installation easy enough. The results, actually, you'll see here in a second, were better than I even expected. This time, it was able to hold the weight of the curtain with no problem. And because there were no breaks in the wire, there was nowhere for the curtain to get caught along the track. So I definitely counted this one as a win.
Wow. Yeah, it's a really elegant solution too. I really like that. The less moving parts that you have in any design, like it always seems like it's just better, more robust. That's cool. You mentioned using like revision management. Can you talk a little bit more about what that is, or like why you would use that in this case?
Absolutely. So let me actually go back for a second to show quickly. When I go to the life cycle tab, so here I can kind of quickly see the different revisions of my design. And basically, when I wanted to make a change, a pretty substantial change to the model, but I also didn't want to mess up everything I did downstream. I wanted to keep those ideas kind of in its own box. I just made a new revision, and that way I could explore in a new space, kind of mess everything up without worrying if I ever had to look back on something I made previously. I could always reference those dimensions later. So that was a bit about how I used revision management in this example.
That's really cool. It's kind of interesting because I guess like maybe I wouldn't have normally sort of just done a save as or something and then just kind of started another part. But then those two things aren't really connected to each other anymore, right? They're just sort of completely different components. So like it looks like here you can actually kind of keep a sort of reference to, these things as if they're a stream of ideas that you're working on, which is kind of cool. Does that come with xDesign? Is that like built in, or how do you have to use that?
Yeah, great question. This is totally included in xDesign, no additional cost. And yeah, you're right. Before I started with xDesign, in the early days of 3D printing, save as was my go-to. So I had kind of a history of the different models I had made. But then I had to take those models, bring them into my slicer, measure what I had done in the past. This is a much easier way to keep all of my original CAD models organized.
Man, that's really cool. Yeah. Okay, nice. Let me check the chat, see if there's any questions popped up for us here real quick. Okay. Let's see here. Oh, okay. Dua FT asks, is 3D Experience like a library for SolidWorks? So yeah, that's a great question. Noah and I have both been using the 3D Experience platform for a little while, and I think Noah's pretty expert at it. You want to give that a shot, Noah? Answer the question for them.
3D Experience being a library for SolidWorks. Yeah, I'd say it definitely can be in many ways. You save everything to the 3D Experience platform, and from there, it's all organized, kind of like a library. So yeah, I'd say in many ways, and that works for both xDesign and SolidWorks, by the way, because all the work you create is saved in a common storage place. So I would say it's kind of accurate. How would you characterize that?
Yeah, I think there's elements of it that are, exactly like that, like a library. Like if you're working at a company and you have a library of components that you guys typically use, like purchase from, vendors and stuff like that, like, all that stuff can be stored on there. I guess people maybe they think of libraries as different things. Like in SolidWorks, we have the toolbox, which is like a library of hardware components, right? But I think it's really like a lot more, because it has, it's like you're saying, like a place that you can store your project data. whether that's CAD data or, supplemental data like PDF files or Excel files, spreadsheets, things like that. But it also has like apps on it, like what you're showing, right? Like xDesign and Xshape and a lot of other cool apps as well. Like you've been working with like other apps like Lattice and generative design apps and stuff like that, right?
Yeah, that's a great point. So it's actually more than just a library. It's also kind of an access point to other tools. So it's not only a library in the sense that it stores, your data, but also stores all of these additional applications that you can use for your projects.
Yeah. And communication with like your team as well. Like, so being able to communicate with them on project stuff rather than it being like in emails that are kind of all over the place and don't really have a thread. And it's like CAD aware, like, you can like reference like this part, for example, like you could reference this exact part in your communication with your team members to like, make sure everybody's like working on the same thing. Plus like a lot of things like project management, you can develop tasks for people. So it's like, it's just so much, but I would say it's just a platform that helps you, get your job done more effectively and more quickly, and more accurately, really, I think is what I boil it down to.
So kind of the world's best library is how I would put it.
Yeah. And although I'm more of like a SolidWorks guy and you're, Noah, you've been, diving into a lot of the cloud CAD stuff. It's like we can both work on the same platform, even though we're using different tools, which I think is pretty cool.
Right.
So, yeah.
Cool. So that's a bit about this project. You ready for the next one?
Yeah, let's check out the next one. Yeah.
All right. So this next one was a fun one. I thought it would be one of the simplest, but obviously as an engineer, you always have to overcomplicate things. So I needed just a place to organize pens and other things in my kitchen, and I had this empty space in my fridge. So I thought, okay, I'll add some magnets, make a little shelf, and call it a day. And so I created it, and then just another failure. Right on with kind of that we were talking before, how the force is perpendicular to to the anchor point. So the shelf did stick, but with the tiniest bit of force, it fell right off, and I clearly had to change the direction that the magnets stuck to the fridge, so it was in line with the force that I was putting on it. So I went back into xDesign, and of course I had to overcomplicate the design as much as possible, just for the fun of it. And this was also a great example of free complexity in 3D printing, because even though this model had geometry that was way more complicated than the last one, the manufacturing process is automated, and it uses roughly the same amount of material, so it really doesn't have a huge impact on the final cost. And for the production, this time I was sure to embed the magnets instead of just taping them like before. I added a print pause in the G-code to drop in the magnets. Then I narrowly avoided injury by getting the plastic away from the moving head.
Yeah.
And this model was really fun to watch print. Most 3D printers today, even really affordable ones, can handle steep overhangs like this with breakaway material, with breakaway support that leaves a decent bottom surface finish. And the result was great. It even had a little flex to it.
Whoa.
It held the pen securely. It was good attachment. And this version actually had less magnets than the one before it, but it was stronger all because of the magnet placement rather than how many there were.
Smart. Okay, I like that. So real quick, like how did you stop the printer? Is that like something that people normally do? I mean, usually I just kind of let mine run. It just kind of goes. I didn't know that there's like a stop involved.
Yeah, good question. There are a couple ways to do it. Some are much more elegant than mine. I just put in a material change. So the reason why you saw it kind of spit a little material out at the front is because the printer thought I was changing the materials at layer, 50 or whatever it was. But in reality, I kind of just put in the magnets, then reloaded the same exact filament, and just kept
Cool. That's a nice way to do that. It's pretty slick.
Yeah,
that's cool. Like I'm kind of thinking like some other uses for things like that. Like if you wanted to put like a metal nut or something like in your print, and that's like encapsulated in there, so it can't like twist around or turn, and then you can like screw something into it. Because a lot of times, like if you screw into some of these 3D printed parts, I'm not exactly sure like what PLA means. I'm assuming it's some sort of like kind of plasticky material. But like it'll, if you're trying to use a machine screw that has like really fine threads, it just won't grip, right? So I had a couple of things where I needed to do something like that. Like I was trying to mount my docking station for my laptop underneath my desk, and I was trying to like screw, like machine screws into this plastic, and it wasn't working. And I was trying to change the diameter of the hole and all this kind of stuff, and it was just not working. But if I could put like a nut in there, that would really like help out a lot, I think.
Yeah, that's a great point. And you definitely can do that. You could definitely pause print, drop in a nut in there, and the bolt will, be using the metal threads instead of the plastic material, which will give way a lot easier. I've also seen people use kind of soldering irons to melt in a metal anchor. That's a pretty popular way. And I've also seen people add holes on the side of 3D prints. So once it's done, they can kind of slide in the nut rather than, drop it in during the print.
Oh, that's even easier. Yeah, that makes a lot of sense. Okay.
But yeah, that's a really common thing that people do in 3D printing to make their parts more robust.
No, I'm gonna ask an annoying question, but can I get this model from you? This thing, I want to print this and like have one on my fridge. I think it'd be really cool.
I'll tell you what, for you, Mark, you could get this model for free. Absolutely.
All right, great.
But no, I'm gonna come back to this at the end of the episode. But yeah, everything I showed today, you will have access to at the Made in 3D community on the 3D Experience platform. That's solidworks.com/made in 3D, and you'll get all of these files to print, to edit, modify, whatever you want to do with them. So good question.
Yeah, on the chat, Sean says that's nice. Looks sturdy as well. Yeah, which I totally agree.
Yeah. So this was a fun one. Next, we're continuing in the kitchen, and I'm always looking for ways to save space. Counter and shelf space are sacred in my New York City apartment. So when I saw all of these cups spread out, I knew there had to be a better way. And also stacking the glass went against everything I learned in the food industry as a teenager working in restaurants. So I had to turn to xDesign. I measured the height, width, and depths of the cups and quickly modeled a couple of shelves in xDesign. And the goal here was to have the legs snap on with no additional hardware or adhesive. I wanted this to be fully 3D printable. And the key were these open areas in the CAD model that let these kind of small dimples flex in and outward for a nice tight fit. I actually learned this technique a while back from Engineezy, who's also been featured on SOLIDWORKS Live.
I remember that one.
Yeah, it's a really great way to securely attach 3D printed parts without any extra hardware or any glue. And that technique made assembly really easy. The legs snapped right in. All of these shelf parts ended up being the same dimensions for this project. So all I had to do was adjust the length of the legs for each corresponding glass. And the installation was simple. I left enough height so you could still access the cups on the bottom, and enough width so the cups on top were stable. And for the time being, I have enough counter space. But I do have a feeling I'll have to come back to these shelves and make a few more down the road.
This is so cool because, I mean, when I have an issue like this and, or not an issue, but like, something I'm thinking of and I want to like organize or whatever, sometimes I just go to like Amazon, right? And I'm just kind of like just scrolling forever to sort of find like, certainly somebody has a solution for this or has come up with some sort of cool shelf system. Like recently I was like, oh, what about like my all the spices that I have, right? Like they're just kind of like cluttered in a cabinet somewhere. And then, what am I supposed to do with this? I'd like to organize them a little bit, maybe get them on like a tiered system, so that I can easily see them and grab the one that I want. I just couldn't find any like good options there. And now that you're showing me this, I'm like, well, I could just kind of follow what you're doing here and just kind of like 3D print something that's perfect for my exact space and my exact, because looks like it's made specifically for these specific glasses on your specific counter, and you can print them in like whatever color you want, which is like really cool. The flexibility is insane.
That's true. Yeah, a lot of customization. You can print them in whatever color. And also, I'm not just going to be sharing the STLs, but I'm going to be sharing the 3D XMLs as well. So again, you can edit these to fit your spice rack, Mark. You can edit these to fit the length of your shelf. You won't just be getting kind of one of those dumb solids that you could kind of just scale outwards or inwards. You'll be getting the actual CAD model that you can modify how you please to fit your specific need.
Okay, let's take a quick break here if we have a little bit of time, because you've mentioned a couple of different file formats now, and I'm familiar with STL. I think most people are. But I think you also mentioned earlier at the beginning of the show something called 3MF, which I think is also a 3D printing format or technology. And then now there's another one that you just mentioned called 3D XML. Could you kind of like give us a breakdown of those three things?
Yeah, great question. I kind of brushed over that, so I'm glad you caught me here. Whenever you're 3D printing, you're using a mesh file, and the typical formats that give you a mesh file are STLs, very popular, probably the most popular. They've been around for a long time. And one of the newer ones is called 3MF. I like 3MF because it carries color data, it carries more information on the model, and it's slowly becoming more popular. So those are the two that you use for 3D printing purposes. Before that, before you have the mesh model, you have more of a CAD model, which is an easier type of file to manipulate. You could see the actual dimensions of the legs, or the depths of the depth of the shelf, even the dimensions of the little dimples that I use to snap the legs into place. Those files are going to be more step files, or in our case, we use 3D XMLs, which is a file format that works best on the 3D Experience platform. Does that clear that up, Mark?
Yeah, absolutely. So anybody that wanted to, take some of these files and try them out in xDesign, they could do that, and they can manipulate it to what their specific situation is. So like maybe they want to change that spring from earlier to a little bit smaller or larger or something like that.
Yeah,
that's cool.
And
okay, awesome.
I'm thinking about it now. Maybe I might actually share the step files as well, in case you want to use this on a different software as well, just to make it even easier.
Cool. Yeah. Sean says, I learned you can embed 3MF inside PowerPoint natively as well. That's pretty cool.
You can actually do that. Great point, Sean. I originally had that in some of these slides. I turned out, well, just stay tuned and you'll see at the end.
Okay, cool.
For our next project, I use that same concept of using kind of the flex inwards and outwards, that negative space to snap components into place. Can you guess what this one is, Mark? It's a common household item.
It looks like a paper towel holder is what it looks like to me.
I can't fool you. You're too good. So yeah, this was a paper towel holder. I designed it in a couple pieces so I could fit it on one build plate. And through that kind of snapping mechanism, the pieces fit together really nicely, and really straightforward project that, again, saved me another trip to the store or another purchase from Amazon.
That's really cool. Okay, so again, yeah, we see the snapping being used there from the last project. That's really nice.
Yeah.
And I like this color too. I mean, that's like, again, there's a wide variety of these colors that you can use to print with, right? You could make a gold one, or you could make a black one, or just to suit whatever your aesthetic is in your kitchen, right? If that's something that's interesting to you.
Exactly. I think this one was Hatchbox Copper. Mm-hmm. Which is kind of a misnomer because I don't think there's actually metal in this filament. I think it's just brown. But yeah, like I said earlier, Hatchbox is a pretty good brand. They got good colors, and I definitely recommend using them.
As I'm watching this 3D print, it occurs to me that this would be another use for that capability to kind of stop the print. And you could, like, in the base, you could like add some sand or something like that to give it like a little bit more weight at the bottom if you wanted to, right?
Yeah, that's a great point as well. That was actually something I considered doing. You could also just increase the infill for that specific part. So you could
Right.
print other parts and maybe like 10-15% infill if they're lighter. But if you need a heavier part at the bottom, you could print that maybe like 40-50% infill. So you're weighing it down with just more plastic.
That's really cool.
Yeah.
Noah, I have to inform you that you've been challenged.
Oh no.
So Carlos 3D World has
Carlos. Yeah.
he has officially challenged you. He says, "I love it, Noah. I challenge you. Let's bring a cool 3D printed project involving coffee to 3D Experience World 26, and let's let the people vote for the most useful." Do you accept this challenge, Noah?
Oof, I'm on camera, so anything I say, the audience will hold me to. I'm not a big coffee drinker, but challenge accepted. You got it, Carlos. That sounds
All right,
awesome.
Carlos, it's on now.
It's on. Another reason to look forward to 3D Experience World. Cool.
That's cool, man. Very cool.
Yeah.
All right.
All right, so I actually skipped ahead, but now you'll see this next one. This next project is my favorite on the list. It's a bit more complicated, and it all started when I discovered that my windows actually opened two different ways. They slide up and down, as you would normally expect, but they also pivot outwards, presumably so they're easier to clean. And I thought that's great for cleaning, but I only saw one thing when I knew the tables went out, or when I knew the window went out like this, is that it has to be a table.
Oh, okay.
Our dining area is pretty tight as is, so if I could add another spot to have a cup of coffee or get some work done, I was going to make it happen. So I used the leveling app on my phone to make sure the window actually came down far enough to be perfectly flat. And once I confirmed that, I started designing some hinges to keep the window locked in that horizontal position. And it took a minute to think through the design. I essentially needed a hinge that would lock in two positions, each perpendicular to each other. And I also wanted to see if I could do this while minimizing the number of moving parts and mechanisms. So I tried to leverage gravity and the way the window put pressure on the hinge to lock it in each position. And xDesign was incredibly helpful here because I could visualize the movement of the entire assembly before I printed any parts. So I was able to add mates and anticipate how the hinge would move both with and without the weight of the window pushing down on it. And it did take a couple of iterations to get the right fit, but once I had it working, I used some double-sided tape to install it here, which really worked out great for this use case because the tape stuck really well to the window frame. I tested that the hinge moved freely as the window pivoted. I did incorporate some wooden dowels just to save on printing time. I could have printed the legs in one piece, but this was just kind of simpler. Or, I'm sorry, I could have printed the legs in multiple pieces, but this was just simpler and faster to use dowels. And I also added some flexible TPU feet for the bottom of the legs for two reasons. The first was so when they would swing back, they wouldn't damage the window. And second, when the legs were actually deployed and in use, they wouldn't scratch the floor.
Right.
And here's the first footage of the gravity hinge in action. I was surprised with how well it performed and how durable the PLA turned out to be. You can also see the xDesign motion test for comparison. Again, it was incredibly useful for planning the motion before I actually printed any prototypes. It definitely saved me on material and print time.
Man, that's incredible. So satisfying.
Yeah, it was really satisfying to watch. And then, of course, I had to get the boss's approval.
So, all right. Okay. Yeah.
My girlfriend seemed to be happy with it. We used it a couple times before the weather got too cold here in New York. And now when it gets nice out again, we'll have another place to sit and get some fresh air while working or having some coffee. So I was definitely happy with how this one turned out.
This is so cool, man. Sean says, this is my favorite, Noah. Never would have thought to do this. Jesse says, this is pretty genius. He also says this man loves his tape. No,
Yeah, the double-sided tape comes in handy. Yeah.
This is so great. I mean, it's so elegant and simple, but like it really it evolves your space into something that's like so much more useful. And it's so pleasant to be there. Like you have your little, you have the window there, it's open, you get the nice breeze coming through. That's so cool. I really like that, you know, you're incorporating, you know, not just like 3D print everything. Like, you know, your mind is in the mode of like, how do I make this functional? Not like, how do I 3D print every part of my life? And so incorporating like the wood dowels makes so much sense because those are they're inexpensive, and, you know, you can cut them to length, and, you know, it's just easy to work with. But like the difficult part, you know, the engineering part that you got to do was how the hinge themselves work and how they lock into place and stuff like that, which is like a super cool design. Way to go.
Thanks. Yeah. And that's a great point too with the dowels. I wanted to 3D print, you know, obviously all the things, but there were certain situations where it just made sense to use other materials, like the curtain anchors, for example. I could have 3D printed like the whole track, but a metal wire going across just made more sense. Both practicality and economical as well. Because if I ended up 3D printing the whole thing, yeah, I could say it's all 3D printed, but it might have actually taken more time and money and materials than it would have been worth it in the end.
Well, there's a lot of people like this. I get wows in the chat and stuff like that. So if you guys appreciate what Noah's showing us here, you know, definitely give us a one in the chat or hit the like button or something. I think this is like just super cool, and it really encourages me to think a little bit more about, you know, the things around my home and like how I can evolve the space a little bit more. So yeah, great job on this one, Noah. I really like this one.
Awesome. That's the goal. I had a feeling this would be the crowd favorite.
Yeah.
Moving on to the next one. This was one of the most functional prints for me. These have actually followed me through several homes because they're so useful. And it all started with my 3D printer setup. This is what it used to look like. One printer on an IKEA table. And that was all well and good until I got a second printer. And I wanted to save space by putting the new one underneath the table. But there was a problem. The new printer I got is about 21 inches tall. And the clearance under the table was only 16 inches. So it wasn't going to fit. And I could have just bought some furniture risers online, but this was a perfect use case for xDesign. I took the measurements of the legs so I could fit the risers underneath. And I also added some screw holes in case it needed to be made more secure. And the installation was obviously very easy, just kind of slid them underneath, and the printer was able to fit. So all of my problems were solved for about a month, because why have two printers when you can have even more with 3 printers?
Yeah.
And the plan for the third printer was to stack another IKEA table on top of the first table and then put the third printer on top of that. But I ran into another problem. The printer I wanted on, or the height of the printer is 19 inches. And if you remember from earlier, the clearance under the table is only 16.
Yep.
So I had to go back into xDesign, this time with a modified riser. And I added those screw holes, which I really had to rely upon this time to make the whole foundation secure. And the results once again worked out. The top table was securely attached to the bottom one with enough clearance for the 3D printer to fit underneath. And from there, I kind of just did a rinse and repeat to make another set of risers so I could fit a third table on top, a third table on top to store filament and tools. And now I can run 3 printers in the footprint of just one. And hopefully it's clear here, Mark. These are multiple pictures of the same stack. I don't actually have 6 stacks of machines.
Yeah.
Yeah.
Yeah, I like that you're crowding the space to have a coffee, but then you got like 23 printers. No.
Exactly. Priorities, Mark. Yeah.
Yeah. No, you're not going to believe this, but here I'm just gonna tilt my camera over just a little bit. My printer is also on top of the same exact IKEA furniture that yours is on top of.
Perfect.
There you go.
There it
Great
is.
minds think alike, right?
If you need some risers, they're ready to go.
Yeah. So yeah, that's awesome. Very cool. Yeah, I like that, and I like that you spent the time on these to make them look nice as well. I mean,
Mhm.
there's an aspect of these that is like, yeah, okay, you just have a functional 3D printed part and call it a day. But adding chamfers and fillets and that sort of thing to them to make them look a little bit nicer and maybe reduce some weight as well in there. You're adding sort of ribs to increase strength in certain directions, but uh, you know, you could also just made a giant big block of plastic, and that would have
Right.
been strong too, right? But I think it's cool that you spent the extra time to make it streamlined and kind of look nice versus just being functional.
Yeah, that's a great point. Just because they're cheap to make doesn't mean they have to look cheap. So I
Yeah,
try to do everything I can to make them look like somewhat of a product you would buy in an actual store.
yeah. So to the chat real quick, Carlos
Mhm.
3D World asks, which type of infill do you like to use the most? And I'm going to add on to that and say, like there's a lot of, when he says which, from what I understand,
Mhm.
there's a lot of, not only like you explained earlier, like density of infill, but there's different geometries of infill, right?
That's right. So basically, they're just different patterns that the 3D printer creates inside of your parts. And those patterns are different based on strength, based on saving material, based on how cool they look, based on a lot of things. Um, I do use Prussia's, and I know Prusia is big on the gyroid infill. So you might be hoping I say that one, Carlos, but I actually always tend to go with grid. I go with grid infill because it's the best balance of strength and material usage and print speed. Typically, things just print faster when they're in grid, at least I find. So that's what I used for a lot of these parts. Great
Okay.
question, though.
So your default is grid just because that
Mhm.
seems to fit most of kind of the designs you're making, but you can adjust them depending on different things, like if you need more strength or if you need a faster print or something like that.
Exactly.
Okay.
Yep.
So Fred Mirzayan, sorry if I mispronounced your name there. He said gyroid for most is what he says he uses. So that's
Mhm.
so I guess that's the cool thing about it is, it's your design. It's what you get to choose what you want to do with it, right?
Yeah, gyroid is the default setting for a lot of um, print, a lot of softwares. So
Yeah.
it's a really good option for sure. I don't want to discount any other ones out there.
Yeah. And Carlos 3D World says I use honeycomb, which
Honeycomb's a
I
cool one. Yep.
yeah, which I think, I mean, that makes a lot of sense, right? That's nature's structural shape, so I think
It's
that's pretty
true.
cool.
Yeah.
But he also uses grid. He says grid is great as well. So yeah. Oh,
Nice.
and also Jesse says just because they're cheap to make doesn't mean they have to look cheap. I think he's right there. I think as engineers we like to, and designers we like to say that form follows function.
Right.
Um, but sometimes it's cool to add a little of your own personality into your designs, right? So I think that's pretty cool.
Yeah, exactly. That's a great point.
Cool. All right, let's
So
let's
yeah,
move
that
on.
was this project. This next one, we're staying in the office, and this was probably one of the simplest CAD designs on this list, but it's also one of the most useful, I find. It's a single sketch, one extrusion, and a couple fillets, but with some double-sided tape, as you know I love, you can turn this into some very capable wire hooks. I originally had some store-bought ones, and I had them for a while, but they were always breaking on me. They couldn't handle thick power cables because they were just too flimsy. So the version I made was printed in flexible TPU, which means the material will bend long before it breaks, if it ever breaks at all. This stuff is incredibly durable. You can see I bend it all the way back, and when I
Wow.
bring it back,
Yeah.
it barely changes its shape. So it definitely won't tear. And I use these everywhere. I use them to organize cables around my 3D printers. I use them by the bed to keep chargers under control. I've got a couple at my desk as well, Just really simple and effective part. So I definitely recommend it. If you're going to take away any from this presentation, to use this one. And if you want to make one yourself, I would just be sure not to use that rigid plastic, because then you'll run into that same issue as the original. Will just break and they won't be able to handle any substantial power cables.
Wow. Okay. No, I'm gonna make one of those immediately, because I have a cable right here that just constantly falls off my desk and it annoys the bejesus out of me.
There you go.
Can you use TPU with most 3D printers, or is it just only special printers that can do flexible materials like that?
Yeah, so it works best with direct drive 3D printers, meaning the motor that feeds in the material is located right on the extruder of the 3D printer. Other machines have Bowden systems where the motor that feeds in the material is actually on the back of the machine, which makes it harder to feed in the flexible material. Most printers, though, can handle this material.
Okay.
I used it on both, my Bamboo A1 and my Prusa Mach 3, and it did a really, really, really great job. So a lot of people tend to be afraid of this material because it's kind of more difficult to print in, but the brand I used, that was the PLA. The brand I used for TPU was SainSmart. It's really reliable. The profiles are already tuned up, so I wouldn't be afraid of printing in it. It's really easy, and like I said, it's super durable. You cannot break this stuff. One of our older episodes, I made the football and the basketball.
Oh yeah, right.
I printed that in this TPU material. I threw it as hard as I could at a wall, and nothing, no scratches. It held up great.
That's really cool. How do you tell the printer, because it has to feed it differently or use different temperature or something like that when it's printing with this material? Like, where is it that you tell the printer that you've got this? Does it do it automatically, or is there some place that you need to tell the printer to use these kind of settings or something for this material?
Yeah, the same way that you tell it how thick you want the layers to print, the same way you tell it how much bed adhesion you want, you also have the option to tell it what type of material you're printing in. This is common in pretty much every slicing software, and a lot of them even have preloaded profiles for specific brands. So Prusa, for example, has a SainSmart profile. So I just clicked SainSmart TPU and it knew what to do from there.
Oh, okay. Nice. Yeah, I see some comments here in the chat about hydroscopic materials, like these filaments. I guess they absorb water, and it seems like that's a kind of a big concern.
Yeah. I haven't had huge issues with TPU, to be honest, or even Hatchbox PLA is really not. It hasn't been terrible. But there are some really good drying options out there. I know the new Bamboo AMS unit has a built-in dryer. There's also a Sunlu dryer that I used to use. So there are products out there that account for those drying issues.
That's cool. Also, Fred M says if you have a dryer, make sure to dry the filament first. If you have a small oven, you can put it on about 100 degrees F for about 2 to 3 hours. Check on it every 15 minutes, but you will be good. So it sounds like you can, just like a lot of the sort of stuff we're doing here today is DIY sort of stuff. I mean, it seems like you can kind of DIY dry your materials as well. I put them in a cereal box and I put some desiccant in there, and I just,
oh, nice.
And I have actually I have one here. Let's bring this guy, but I have this guy.
Perfect.
And it has just a little meter in there that tells me what the water hydration content is in the box. So
that's an amazing solution. Not just the fact that you have the the dissonance in there?
Yeah, desiccant material. Yeah,
desiccant material in there, but also you have a monitor, so you know exactly how dry it is.
Yeah,
so that's great. Yeah.
Cool. All right, I love this. I'm gonna print a couple of these immediately. Although I just have the PLA material, so I'll have to buy some TPU and do that. But I mean, it'll work in PLA, right? It's just it'll be a little more brittle.
Yeah, it'll work, but The thing is, if you pull it too far out, it probably won't come back in.
I see.
It'll
Okay.
deform. If it doesn't break completely, it'll just it won't be as tight as it was the first time that you printed it.
Okay.
Yeah.
Cool. Great job.
Yeah. So this next project is another hook, but this time for much heavier weight. I wanted a strong wall hook for bags and backpacks, and I also didn't want to see any exposed hardware. Like we were saying before, it might be cheap, but it doesn't have to look cheap.
Right.
I wanted to hide the screws, and so I started with the hook in xDesign, and I subtracted the wall connection, added a couple screw holes, and after about 20 minutes of printing, it was ready to install. Again, I recommend hand tightening any PLA parts instead of the drill, where you risk kind of crushing them or breaking them in parts. And I was a little worried at first whether this hook was strong enough, but with some good wall anchors, it's been rock solid and really functional.
Yeah, I mean, yeah, there's a lot of factors that go into this, but you can always get wall anchors that can handle 50 pounds or, whatever it is, right? Even if it's drywall or whatever the material is you're screwing it into. So that's really cool. This is a really cool two-part design where, yeah, you create a hook that satisfies your design need and that it looks nice on the wall, but yeah, like it doesn't look cheap. It looks great, and yeah, it hides the hardware. I mean, that's excellent. I'm sure
I like this one. It was kind of a no frills design. Just does what you need it to do, looks decent, and you can move on to your next project.
I think a lot of times with these projects, we have sort of a spouse approval rating, or like roommate approval rating kind of thing, where
right.
If you just kind of put a bunch of like plastic on your wall, the people that are sharing the space with you probably may not be happy with it. But when you design something that's beautiful like this, and functional, then and everybody's happy. Everybody wants one. Like, hey, put a couple of these in my room, or put a couple of these in the kitchen, for aprons or whatever, right? So that's pretty cool.
Yeah, this one was, I think, higher on the approval list, just because it didn't look so much like a 3D printed part. Just looked like something you'd buy from the store.
Yeah.
So now, to close out the list, I have a few more.
Oh wait, sorry. Actually, one second. Yeah. So a couple comments in the chat here from Jesse. First, he's saying it's a great episode. He's really enjoying it. Thanks, Jesse. And Fred also gave a +1 on that. But Jesse has a question. How do you figure the gaps on slip fit parts like that? That's a really good question, because yeah, sometimes with 3D printing, the tolerances are sometimes a little tricky, like depending on if it's an outside wall or an inside wall. So like, how do you first determine what sort of tolerances you need, and how do you build those into the print?
Yeah, that's a great question, especially for a model like this, because the first time I printed it, there was actually too much tolerance, and I had to print it again. My rule of thumb is anywhere from 0.1 to 0.2 millimeters of clearance.
Okay.
0.2 millimeters is usually, it'll slide very easily. 0.1 is you're going to get more friction. This specific model, I believe, was 0.1. When I first printed it, I added 0.2, and it slid in very easy, but I could actually pull the hook away a little bit because there was too much clearance.
Okay.
It had, so yeah, I went with 0.1, decreased it, and now it's a really snug, tight fit. So rule of thumb, 0.1 to 0.2. And it's a spectrum, anywhere in between. If you want to go 0.5, so maybe it's friction. There is some friction, but not too much. This part is moving more than usual. You could go that route. For this, I never really wanted it to move. So I was able to go all the way to the bottom of the spectrum, go 0.1, and once it fits on, I should never have to move it again.
Okay. And that'll change based on the printer too, right? Because different manufacturers, different print technologies will all kind of like be a little bit different in that area. But that's kind of the area that we're looking at.
Yeah, that's a good point too. I would say the newer machines can handle lower ends of the spectrum.
Okay.
Close to that 0.1.
Now, I know we're getting close on time here, but there's a really good question that just popped in that I think, you might be able to help us out with. NTUYOEDWIN, sorry, I don't know how to pronounce that, says, what can be the best printer recommendations for my personal projects just to start some 3D printing? And maybe not necessarily like, we don't want to necessarily recommend a specific printer or brand, but maybe you can quickly help the audience with, what should they be looking for like kind of an entry level printer?
Yeah, I would say for entry level printers, well, that's kind of the beautiful thing about today's day and age in 3D printing. There are really affordable printers now for like $300 that can handle good accuracy. They can handle anything on this list that I'm showing you. So if you're just starting out and you don't want to get too far in, maybe you want to go with kind of a bed slinger 3D printer as opposed to a Core XY. And when I say bed slingers, those are the machines that I showed earlier, where literally the bed is slinging back and forth.
Right.
That's what they call them. Whereas Core XY, the build plate goes up and down. And I say that because the bed slingers tend to be more inexpensive and they're quieter. They're not as much of a burden. You kind of don't have to worry about them as much. You kind of just go in the corner, print, do their thing, and you don't have to think about it. So, and like I said, there are tons of brands you could go from, anywhere from Bamboo, Prusa, Creality. There are tons more. So you don't even have to recommend a single one. A lot of them can handle entry level needs where you don't have to think about the printer too much. You just get it printing and that's it.
Okay, great. Yeah. Okay, yeah, let's continue.
All right, so I know we're at the end here. To close out the list, I've got a few more fun ones just for home and holiday decor. And these may not be the most functional in terms of everyday use, but they definitely fit the criteria for being affordable and economical. They save me from having to go to the store or shop online for something that I probably just throw away after a season. And also, several of these helped with my third goal of improving my CAD skills, because many of these used a technique that I'm still perfecting, subdivision modeling. And you can't really talk about xDesign without mentioning subdivision modeling. It's a really powerful and unique feature that adds a whole other layer to your designs. And I say it's unique because while there are other subdivision tools out there, not many of them are built to work hand in hand with parametric modeling the way it is in xDesign. So you could go straight from modern sculpting workflows to traditional 2D sketching workflows in the same part. And I didn't use subdivision on kind of the other more functional items in this list because I wasn't really focused on making them organic or ergonomic. But if I were to turn any of them into actual products, you could be sure I'd use this type of design workflow. I also mentioned these projects were a great way to stay up to date with the constant updates being pushed out for CAD. For this pumpkin model, I used the new subdivision normal robot feature, which was just released last week into xDesign. And that's just another benefit of working on a cloud tool. You don't have to download updates. You don't have to run any installations. You're always working on the latest version with all the latest features. So those are the projects I wanted to share. I mentioned they were able to save me a few trips to the hardware store and keep me from ordering online. I thought it'd be fun to guess approximately how much you think I saved by doing these projects myself. So drop your best guess in the chat. Add together what you think the average cost of these items would be if I bought them instead. And obviously all these are very rough estimates. I don't guarantee any of these prices. So what are you thinking, Mark?
Oh man, okay. So for the door catch, I guess if you were going to just replace the existing magnets and stuff there, that might be like, I don't know, like $10. I don't know how much it costs for like a replacement of those. I don't know what like the filament cost, but from what I understand, it's pretty inexpensive. So like to 3D print those two little pieces was probably like I'm going to guess like 50 cents or something.
Right.
So
Yeah.
I'm going to estimate maybe around $9 savings.
Do you have an
That'd be
estimate
my guess.
for, maybe I could have made it clear, an estimate for the total amount that,
Oh, of everything?
yeah.
Oh man. Okay, hold on. Yeah, let's
Quick math in the head.
see.
Quick mental math.
Yep. All right. So, okay, door catch. Okay, curtain track, right? So the wire and pull that over. Man, those things can be a little bit more pricey. Okay. So I'm going to add, I'm going to say 10, let's say it's up to 30. Paper towel dispenser, I know that those can be expensive, but like an inexpensive one might be another $15 or something. So it's 45. Kitchen shelf thing, I've actually shopped for those, and yeah, for a 3-pack like that, yeah, you're going to look at another $15. Let's say 60. Fridge
Yeah,
magnet.
those are more expensive than I thought, the kitchen shelves.
Yeah, they can be. If they flat pack, it's a little less expensive, but yeah, if they don't, then it's a problem. Fridge magnet organizer. Yeah, I like that one. Okay. I've never even seen one of those, so I don't even know what that would be. Table risers. I mean, the thing is like not even a cost issue because that's so specific to your exact situation. You wanted a table riser that's an exact height. Like I know they make risers for beds, for example, like, for kids' beds or something like that. But yeah, this is like, so even the cost here doesn't even express like how useful using this workflow is. Wall hooks, sure, your wire hooks. And I mean, and also like the thing that comes down, like your window, like coming down, and like there's nobody that's making products for that, for like your window. So I don't know, if I had to just put a number on it, I would say like $120. I would say.
Wow, well done. So the final number, my estimate, would be 130.
Okay.
Great guess.
Now let's see if we got any in the chat here.
Yeah, I think we had like 110 in the chat. So
okay,
great guess. Whoever did that one.
Yep. Tristan says 110. Fred says the door catch is 12 cents. So okay, that's cool.
Right.
Sean assumes $320. But that might actually be accurate, especially if we're incorporating like that window thing that comes down. I mean, like that would have to be like a special ordered part from somewhere. I don't even know how you would find something like that.
Yeah, I didn't even include that one on this list because I wouldn't know how much to even charge for something like that. And you made a good point before, with this number, I didn't incorporate any time spent or material cost. But what I can say is, when I mentioned printers before, you can get a really good one now for like $300. So if you found anything today helpful and things that you actually want to make yourself, you're already pretty close to justifying the cost of a 3D printer because they are very affordable. Yes,
I love this ROI at the end of the show where it's like, justify me getting a printer. I love it. Yeah, that's what I'm after here. Yeah, that's what I need.
That was the plan all along.
Yeah, that's so great. Yeah. Okay, cool. So I guess we're wrapping up here. Some questions that come to my mind are the tool. We talked about entry-level 3D printers, how everybody can kind of get a 3D printer for relatively inexpensive and get started on some of these projects themselves. So that's really cool. Is there a way that people can get some of the CAD tools or get access to some of the CAD tools or try them out just to see how they like them?
You can tell the future, Mark.
Okay.
So
yes,
if you're interested in any of these projects and making these models yourself, you can try xDesign today. So there's a professional license for bringing commercial products to market and a maker's license that's now just $48 for the entire year. So it's about $4 a month, roughly the price of a cup of coffee, really low barrier to entry and perfect for home projects and personal projects like the ones I showed today. So I definitely recommend the maker and hobbyist option to try it.
Awesome.
Yeah.
Very cool. All right. So are we wrapped up here?
That's all I have today. Thanks, Mark. Thank you to the chat for having me. And thank you to Sean and Jesse on the back end as well for always making the show run smoothly.
Yeah, absolutely. Yeah. So yeah, thanks Noah. This has been an awesome deep dive, and I'm really excited to print some of these myself and get some of these models. Where'd you say the models were at?
I'm going to share them in the Made in 3D community on the 3D Experience platform. That's going to be solidworks.com/made in 3D.
Awesome. Okay, so everybody, join us there in that in Made in 3D. I'm going to be there. I'm going to check out some of these parts. Noah, thank you so much for sharing your passion and your knowledge for 3D printing with us. It's been incredible. It's fired me up. I'm ready to get started doing some more things around the house too. So I think it'll be awesome. So I want to thank everybody that joined us today. If you learned anything, give us a like on the video. That just helps, our videos get out to more people. And if you'd like more videos like this, definitely subscribe to our YouTube channel. Check out, all of the content that we have available here. Lots of episodes of live design this year, again, that are kind of the deep dive style. Lots of live designs from previous years that have a great amount of information. So check out our channel. There was somebody in the chat that actually mentioned looking for some information on how to get better at surfacing, for example. So this would be a great resource for that. So just go to our page on YouTube and go to the search box and search for surfacing. And you're going to find a lot of really cool content there. So, yeah, thanks everyone again for joining us today. And we hope to see you next time on SOLIDWORKS Live Design.
Thanks, everyone.